Hi, my name is Rob Davies. My advisor was Tally Freed, and for my senior project, I did a tests and new products database for Company X.
I'd like to begin by giving a quick background of the company and the internship. Company X is a successful winery with multiple bottling lines. It's important to note that I worked on the actual bottling lines and not in the grape fields. My position was the technical services intern. In my position, the main focus was to report on tests and new products coming out to these bottling lines. I would send out a 2-week outlook every week with all of the tests and new products. In order to manage this 2-week outlook, I kept a database. This database was used to add, track, and report all new products and tests on the bottling lines.
For my senior project, I actually created 2 different database systems: a test system and a new product system. Because I do not have enough time during this presentation, I will only go through the new product system since it was the most beneficial to technical services. Before I can explain the new products database, I need to explain what new products are. A new product is any new good or any change to an existing product. A new product is affected by both projects and SKUs. A project is initiated to change a process, equipment, line, or package. These projects in turn affect SKUs. And what a SKU is it stands for a stock keeping unit, and is a basic value given to an individual product. Each time a project affects a SKU in a package way or a line way or any other change, the SKU is versioned up. As you can imagine, at a large company like Company X, multiple SKUs are changing every week. These changes need to be captured by technical services to be reported to the entire company. When I arrived at Company X, the database used to track and report on new products was more of an Access spreadsheet. This spreadsheet would include such things as bottling date, brand, and a notes section holding all of the key information that the rest of the company needed to know. Each week, I would need to manually go into this spreadsheet and change all of the data if it had changed the week before. In order to find out what new products are going to be bottling in the next 2 weeks, and what key information I need to hold in the notes section, I needed to go off of what I learned in meetings and what I could find out by word of mouth. From this Microsoft Access database, a single basic report was made. This report was the 2-week outlook. There were many key problems with the database that I focused on in creating a new database. First off, there was no automation. Everything had to be manual. This led to no new products tracking. There was no way to track bottling dates as they go through their lifespan. Also, when a new SKU hits the bottling line, there is no way for me to see it. I had to assume that everything I needed to know I found from new employees and from my meetings. Lastly, with the new products tracking, there were multiple systems that I needed to use in order to track a SKU as it goes through its lifespan. 2 different systems tell you very important information about each SKU. One system tells you the bottling date, while another system tells you what project goes with that SKU. Because there was so much manualization, many of the new products were missed. I was not able to keep up with all of the different new products that were hitting the bottling line. Consequently, because of these new product misses, major strain was brought upon both operations and scheduling. Operations would need to find a way to bottle something that they are not prepared for, while scheduling would need to rearrange the schedule in order to take into account the major downtime that these new product misses would cause operations. The last database problem was the immense amount of time it took me to run a single report. Each week, I would spend an entire day trying to get the single 2-week outlook report correct. There were 2 key reporting problems with the old database. First off, the reports did not show some key information that's needed to know by different departments. Some departments need to know a simple yes or no answer on certain new products. Next, there was no further outlook than 2 weeks. In many instances, 2 weeks is not nearly enough time to prepare for certain new products. As I mentioned earlier, in tracking new products, I had to use multiple systems. So, in designing a new database, I had to keep these three systems in mind. System 1 contained all projects that were active at Company X. System 2 gave a spreadsheet of all bottlings at Company X per each SKU and shows the line that it's bottling on. Lastly, System 3 contains all engineering change orders, or ECOs. This gives the project information for each SKU. With the three systems in mind, two databases were created that were linked together. First off, the project database. This database gave the ability to import a project Excel sheet. Once a project is imported into the system, key information can be given to the project. Then there is a SKU database. This database connected the systems 2 and 3, basically being able to link bottling date with the project information per each SKU. Now, both of these databases work together to be able to find, track, and report on all of the new products. This slide shows an entire overview of all of the new product system, showing both of the databases working together, and showing the system that it's using per each step. First off, in System 1, all projects are imported into the database. Each of the projects is then given an information. Next, as a new SKU hits the bottling lines, one of the databases catches this. Once it's caught, it imports the SKU into the database. Then, once the SKU is imported into the database, System 3 finds the SKU and then finds the ECO report given per each SKU. By using this, we are able to link both the project and the SKU. Then, the system uses System 1 again and trickles down all of the project information for that SKU. System 2 then is used to track the SKU as it heads to its first bottling. There were some important advantages brought about by this database. First off, the database was able to notify as new SKUs hit the bottling lines. Also, the database was able to track a SKU as it goes through its lifespan. This caused for no new SKU to hit the bottling lines not being reported by technical services. Next, because SKUs and projects are linked, all SKU information was automatically updated by the project. This decreased the amount of time typing into the database significantly. There were also some key advantages to the reports created by the database. The reports created gave simple yes or no fields to give the key information needed by certain departments. Also, multiple reports were able to be created. For instance, an 8-week outlook was created in order for technical services to be able to track new products further out than 2 weeks. This is a sample report of the tests and new products 2-week outlook that is sent out by technical services every week. As I mentioned before, we don't care very much about tests for this presentation. However, in the new products portion, there's yes or no fields giving key information about each SKU. Because technical services would be using this database and relying on it, major testing needed to be done and there needed to be a slow implementation. These steps were taken in order to make sure that the database was correct for each report. In implementing this database, a manual was created. This manual gave step-by-step instructions on how to complete each of the database functions. Lastly, meetings were set up with a technical services manager to go through how and why each database step is needed. Economically speaking, there were a few benefits that the database created for technical services. First off, the most important benefit was that no new products were ever missed by technical services. All new products were reported on, and both operations and supply chain now knows about. This benefit is difficult to quantify. Secondly, because the technical services intern position has a lot more time now, the position focuses more on process improvement. To quantify the numeric benefit of the database, I had to make some estimates before and after the database. First off, before the database, I estimated that I spent about 10 hours a week operating the database. This is because I spent an entire day going through the 2-week outlook to make sure everything is correct, while the other 2 hours are hours that I spent in meetings learning of what new bottles are coming up in the next 2 weeks. After the database, everything could be done very, very quickly, because everything can be done with just a few clicks. This caused for the 2-week outlook to be reported in under an hour. To calculate the savings, I assumed that the intern used the database 80% of the time, while the manager used the database about 20% of the time. Using these figures, I came out to a savings per year of about $11,000. The other savings to be calculated were the savings from the decreased downtime that came out of the new database. I estimated that on average, about 1.3 hours were saved each week. Because the average downtime cost per all the lines averaged together was around $300, the cost savings because of this decreased downtime was around $20,000. Adding up the technical services benefit as well as the downtime benefit, this came up with a total annual savings of about $32,000. This concludes my presentation on the new products database. Thank you for your time.